Hey guys, what's up? So today I'm going to try explaining how to calculate the area of a circle using integration. And yeah, so this is my best attempt at drawing a circle. And what we know about the circle is that since this is y, x, and r, we can say that y squared plus x squared should be equal to r squared, meaning y squared should be equal to r squared subtract x squared, meaning y is the square root of all that. Okay, we already have the hard part out of the way, and now all that's left is just integrating this. So we have to integrate in from 0 to r of this function. R squared subtract x squared, obviously in respect to dx, right? So what do we do from here on out? From here, well, if we look back into the circle, and that's our circle, right? We have a theta over here, a y here, x here, and r right there. If you guys know your trig, you know that x is going to be equal to cos of theta times r. Let's plug this back into our original formula. Oh, and multiply this by 4 since we have 4 different sections and this only calculates one of them. So we have 4 times the integral from, let's leave that for a bit since we're changing our, what we're integrating in respect to. We'll put this later. So now we have to substitute everything. We have r squared subtract r squared times cos squared of theta in respect to x, which is r times cos of theta. Okay, now since we're integrating in respect to theta, we gotta change the measurements, and we can do this in radians. So now this becomes a pi over 2, and this is a 0. Because as I said, this is radians, right? So pi over 2 is here, and the 0 is over there. Okay, it's starting to look a bit more confusing, but let's try to piece this together. Let's take your like terms and, simplify. So we have 4 times the integral. Well, we see an r squared repeating there, so we can take that out. R squared times 1 subtract cos squared of theta in respect to r cos of theta, right? And let's try understanding what this term really means. It's an infinitely small term, right? That's what the d of whatever is. But there's a way we can represent it, and it's gonna be necessary, right? So actually, let's just finish this part right here, right? So we have the square root, so what we can do is distribute it, so we have r times the square root of 1 subtract cos squared of theta. Well, this is a sine squared of theta because 1 is equal to sine squared plus cos squared, and this is of course in respect to r cos of theta. Okay, so now we have 4 times the square root, the integral of r times sine of theta in respect to r times cos of theta. Okay, well, this obviously seems impossible because cos, sine, they don't go together, right? Okay, so now comes the big part. We gotta change what we're integrating in respect to. So right now we're integrating in respect to x. Sort of in respect to x. So what we can do is x is equal to a function of theta. Okay, so right now we can take the derivative of x in respect to theta. So we have dx over d theta. Remember, since x is equal to cos of theta times r, the derivative of cos of theta is negative sine of theta. So we have negative sine of theta times r. We want to have our dx by itself, so we multiply both sides by d theta. Remember, d theta is an actual value. It's a value that reaches 0, and it's pretty much this. As the limit of n goes to 0, right? So that's what our theta is. So we can actually do this procedure. Okay, and so they both go away, and now we know that dx is equal to this value right here. Now we just have to substitute. So we can say this is equal to 4 times the integral of r times sine of theta in respect to our new stuff. multiplied by negative sine of theta, multiplied by r, and obviously in respect to theta now. Remember, don't forget what we're integrating from. Okay, cool. Let's move this down, and let's take anything that doesn't have theta in it out of the integral, because obviously it's not going to play any role in it, right? So r doesn't, we don't need r in theta, so we can take that out. So now we have 4 times r squared and the integral, right? Which is this. Take the negative 1 out too. So this is a negative sine of theta. Well, this is actually just equal to negative 1 times sine of theta. Well, it can be expressed as that, so take out the negative 1. Okay, this is starting to kind of look like the formula. We have an r squared, which is a good start, right? But we're not done yet. So what is sine squared really equal to? Well, let's find another way to express it, because we can't just calculate sine squared in respect to theta, right? So we know that cos of two angles that are the same is equal to cos squared of theta subtract sine of theta. So what we can do is we can add 1, which is just equal to cos theta plus sine theta. And actually, since we want to calculate sine theta, let's not add 1, let's subtract 1. So we're going to subtract it by this, which just gives us, which the coses cancel out, and now we have negative 2 times sine squared of theta. Okay, cool. Very cool. Now, what do we do to get sine squared of theta by itself? We divide by negative 2. Okay, so what did we do? We took this, subtracted 1, and divided by negative 2. So we can say that cos of 2 theta subtract 1 divided by negative 2 is equal to sine squared of theta. Okay, there you go. We plug this back in and we're almost done. So now we have negative 4 times r squared times the integral pi over 2 to 0 of cos of 2 theta subtract 1 divided by negative 2 in respect to theta, of course. Okay, let's do this again. Take out whatever isn't necessary out of the integral. So negative 2 we can take out, so negative 4 divided by negative 2 is just 2 times r squared times the integral from pi over 2 to 0 of cos of 2 theta subtract 1 in respect to theta. Now if you guys have been doing integrals, you guys should be able to solve this now, and we'll just do it together, right? Let's get a new paper so that it's not too crowded. Let's not skip so much paper because I kind of want to use this, you know? Okay, so this is our integral. 2 times r squared times, hopefully you can see that, 2 times r squared times r integral from pi over 2 to 0 of cos of 2 theta subtract 1 in respect to theta. Okay. Okay, cool. So we know the integral of cos of any angle is just equal to negative sine. So we now have 2r squared times negative sine of 2 theta, and we know the integral of negative 1 is just negative x, and now we have to integrate. We have to integrate from pi over 2 to 0. Okay, that means we start with 0 and we subtract by whatever pi over 2. We substitute theta for pi over 2. So now we have 2r squared times, and we'll solve this, negative sine of 0, subtract 0, subtract negative sine of pi over 2 times 2 is just pi, subtract pi over 2, and close all that off. Okay, this looks kind of complicated, but let's look at our circle. Okay, this is not even close to a circle, but we're going to pretend it is. And there you go. Alright, sine of 0. Well, that's 0, right? sine of pi. That's again 0. The heights they don't exist, so they're 0. Alright, we literally just solved all the hard parts. This is a 0, and that's a 0. The negative signs, of course, don't make a difference, right? So now we have 2 times r squared times 0, subtract 0, subtract 0, subtract pi over 2. Alright, now, you guys should be able to do this from now. Okay, 0 subtract 0, that's 0, of course. 0 subtract 0, that's 0. And 0 subtract negative pi over 2, well, that's positive pi over 2. So now we have 2 times r squared times 0 plus pi over 2, which is just equal to 2 times r squared times pi over 2. Alright, now what do we see? We see the 2's cancel out, and now we just have r squared times pi. And there you go. So I hope you guys enjoyed the video. If this helped you out, leave a like, and thank you for watching.